In this topic, student will be able to state law of mass action, define active mass, derive the expression for the equilibrium constant. Student will be able to define equilibrium constant, describe the conditions of equilibrium and recognize equilibrium. Law of mass action and derivation of the expression for the equilibrium constant. Two scientists, C.M. Goldberg and P. Wage, proposed law of mass action in 1864 to describe the equilibrium state of a chemical reaction. Law of mass action. The rate at which a substance reacts is directly proportional to its active mass, and the rate at which the reaction proceeds is directly proportional to the product of the active masses of the reactant. Now, what is the meaning of the active mass? Active mass represents the concentration of the reactant and product in mole dm cube for a dilute solution, and it is expressed in terms of square bracket. Consider a hypothetical reaction. A react with B and form products C and D. In this reaction, small a is the mole of the reactant A, B is the mole of the reactant B, C is the mole of the product C, D is the mole of the product D. In this reaction, forward reaction is A react with B and form products C and D. Reverse reaction is product C and D decomposes and form A and B. According to law of mass action, rate of forward reaction is directly proportional to the product of the concentration of the reactant A and B. Now, rate of forward reaction is equal to constant for forward reaction multiplied by the concentration of the reactant A and concentration of the reactant B. Rate of reverse reaction is directly proportional to the product of the concentration of the product C and D. Now, rate of reverse reaction is equal to the constant for reverse reaction multiplied by the concentration of the product C and the concentration of the product D. Here Kf and Kr and Kf are the rate of constant for the forward and reverse reaction. When the equilibrium state attained, the rate of forward reaction is equal to the rate of the reverse reaction. Now put the values of rate of forward reaction and rate of reverse reaction. When we put, we get constant for forward reaction multiplied by the product of the concentration of the reactant A and B. It is equal to the constant for reverse reaction multiplied by the product of the concentration of the product C and D. Now rearrange the equation, we get constant for forward reaction is equal to Kr multiplied by the concentration of the product C and D divided by the product of the concentration of the reactant A and B. Now arrange the equation, we get Kf upon Kr. This is equal to the product of the concentration of the product C and D raised to the number of the mole of C and D divided by the product of the concentration of the reactant A and B raised to the power number of the mole of A and B. Now Kf upon Kr is equal to Kc. Kc is the equilibrium constant, and this C subscript C denote molar concentration at equilibrium. Now put the value of Kf upon Kr is equal to Kc. We get product of the concentration of the product C and D divided by the product of the concentration reactant A and B. Kc is equal to equilibrium constant. The equilibrium constant. Okay. Now this C, capital C, is the concentration of the product C. Capital D is the concentration of the product D. This small c is the number of mole of product C. This small d is the number of mole of product D. This capital A is the concentration of the reactant A. This small a is the number of mole of reactant A. Capital B is the concentration of the reactant B. Small b is the number of mole of reactant B. Now the definition of the equilibrium constant. Equilibrium constant is defined as the ratio of the product of the concentration of the product to the product of the concentration of reactant, each raised to the power equal to the coefficient in the balanced chemical equation. Look at here. This division line indicate it is the ratio between these two values. Okay. And this ratio is between the product of the concentration of the product raised to the power equal to the coefficient in the balance equation. Okay. And this is the ratio to the product of the concentration of the reactant A and B raised to the power equal to the coefficient in the balanced chemical equation. Here the product of the reactant means the multiplication of these two concentration of the reactant. Okay. And here the product of the concentration of the product means the multiplication of the concentration of the product C and D. Now student, conditions of equilibrium. There are some conditions for the equilibrium state in a balanced chemical equation. Number 1, concentration of none of the reactant or product is changed. Temperature of the system is kept constant. Pressure or the volume of a system is kept constant. Now ways to recognize equilibrium. Equilibrium state of a chemical reaction can be determined by determining the concentration of a reactant and products at a regular intervals. It can be done by a physical method or by chemical method like spectroscopy and titration, and there are many other ways to recognize chemical equilibrium. Dear student, this is a self-assessment exercise 9.2, and this exercise you should derive equilibrium constant expression for the given reactions.